Radio.net land again. Why am I here and who are you guys?
Hey, I'm Britt Johnston. I'm the Director of Program Management.
I'm Mike Pizzo. I'm a software architect on data programmability.
All right.
And I'm Pablo. I'm the AD.NET technical lead.
Yeah, we've seen you here before.
Yeah, I happen to land here quite often.
So what are you guys working on? What are we talking about today?
Well, we wanted to follow up on the discussion you had with Anders and Sam a couple weeks ago, or maybe a week ago, and follow up with some more detail. So we thought we'd respond to a lot of feedback we got from customers who looked at that last thing and wanted to get more. So here we are to get deeper.
All right, let's do it.
And in particular, we're talking about the ADO.NET Entity Framework.
Okay, so what is an entity framework?
Well, why don't I start out with a little bit of history? I'll use the whiteboard here a little bit.
Okay.
I think if you look back at how apps got built in the late 80s as they responded to the sort of rise of the relational database, so some interesting things happened. One is that people had this database that they built, and they started building applications on top of that. And the applications itself, represented here, were really built in terms of this what we call today logical schema. It's what people think about in terms of tables and columns and that sort of way of thinking about data. And so they built those apps that way. And then along came programming languages, and they really pushed the envelope in terms of how you think about writing code. Mm-hmm. And they created this whole world of thinking about things in terms of objects. So the model moved up. So now we have the expectation that users get apps and people write code in terms of the concepts of the application itself. So we get to the conceptual. And so what happened over time is as the app now moved to a richer function, a layer appeared inside these systems, and where really what that did is it mapped between the logical model here and the conceptual here. And so we had this transformation occurring between the logical database and the conceptual application, and this got codified in a layer in the system. A lot of people think of this as their data access layer. They may actually buy a piece of software, a piece of middleware now that this is matured to, called Object Relational Mapping Technology, or ORM. Mm-hmm. So what we're responding to in terms of the next generation of data access technology is what our customers have told us, which is they are tired of maintaining this layer in their system. And what we can do is actually allow them to build their app so that they stop here. They can effectively get rid of this piece of code. So their next app that they build, potentially, they can still use the same logical schema they have down here. In fact, there may be years and years of data that's all stored in that manner and tons of apps that require it. So we can't just change that.
Sure.
But they want to build the next generation app using this concept. And so if we can let them build code at this layer here, they're going to write less code. So this is all about writing less code, saving people money, and building a better platform for them.
Fantastic.
So that's what we're all about here. So what we want to do is, based on that kind of explanation, is drive into some detail here. Pablo's gonna jump in.
But let me ask one quick question.
Sure.
Clearly, you can't get completely away from this because stored procedures are going to be necessary.
That's right.
When you're dealing with complex databases, you're going to have to
That's right. You may have stored procedure down basically inside your database.
And this is actually what you're talking about is the layer that interacts with the SP.
Interacts with it. So what we want to let people do is express their application. If it needs to use stored procedure, it can do it at this layer. So rather than having to have them map that into the stored procedure within their own code, we can do that for them.
Fantastic. All right. So can we talk about how you pulled that off?
Sure.
Mm-hmm. Right.
Let's dive in.
Pablo gives an overview of what it looks like.
Okay. We're going to do some coding.
Show me the code.
We're going to do like a couple of iterations over this. So the idea here is first so one of the things that Britt highlighted was this productivity deal where we go like, okay, how do we get people to write less code and be more productive when writing applications? Mm-hmm. So we're going to take a quick look at that first and do a very straightforward thing where we still use the database the way it is today, but we just use it within the new AD.NET Entity Framework. And then we can start pushing the envelope on how much more expressive we can be when we're using the Entity Framework instead of just hitting the database using a traditional data access stack.
Okay.
So
I'm going to zoom into this.
Okay.
All right.
So I'm going to start with an empty app. The only thing I prepped here is I put some configuration information. You can see here, this is just a connection string, so I know what server and what database I'm referring to. So what I'm going to do here is I'm going to add a new element to this application, and this is going to be an EDM model. And we're going to talk about EDM more in a second, so just bear with me for now. I'm going to name this, let's say, AdventureWorks v3. And so I'm going to build a model that represents the view of the store that my application is going to use. So the idea here is that you have a store, which is the database that you use for your app, and you have an application. That application expects a certain model that is sort of embedded with the data. And the question is whether that model has to follow exactly the schema of the database, or whether you can have a schema that is appropriate, or a view of the data that is appropriate for the application you're writing.
Okay.
So this is this model I'm writing here. In this case, I already have a database, which is, in this case, it's a small subset of the AdventureWorks database that comes with SQL Server. So I'm going to just sort of reverse engineer the database into a model. I'm going to say I want to talk to my local server, and the database I want is this guy here. Click OK. So the system pulls all of the tables and stuff and sort of pulls together a drawing. We can zoom in on this a little bit. That represents the elements of my database. In this case, what I have is one of these elements for each table. I'm going to explain in a minute better what this is, but for the time being, let's say that each one of these guys represents the structure of each one of these tables. And this guy here represents the database as a whole. So for example, I have a table called sales order, and a table called salesperson, and so on. And I have the database and each one of the tables that are accessible in each database. We can tweak this a little bit. Like in this example, this table here I don't want, so I'm going to get rid of it. This table from here I don't want. I can call the actual entity sets, which is the tables. We're going to go into more definitions in a second. I can tweak the names a little bit. For example, I want to say salespeople instead of person. We're going to say employees, contacts, and sales orders.
Now, to be clear, what he's doing here is he's not changing the schema of the database itself. He's just changing the view the application has of the existing relational database schema.
Okay.
So that allows the application to work with a subset of the schema without having to change the database.
Okay.
So a couple more tweaks. Let's adjust the cardinality of these guys, and I'm gonna rename this to something we can actually read, like AdventureWorks DB. And now we have a schema that represents the view of the store for this particular application. Now let's use this. So when I save this, what the system generates is the schema itself, which we use is metadata basically, and we use for the system to do its tasks. And also we generate a bunch of .NET types or classes that represents each one of my business objects.
Excellent.
So now I can go to my form, and in this case I'm going to use object binding, which is a .NET 2.0 feature, a Visual Studio feature. I already prepped the sales order object, which is one of the orders, one of the schemas that we imported from the database.
Okay.
I'm going to take this guy, drop it here. Object binding does its thing, and it draws, a nice form and all the stuff in there.
Very nice.
And now let's say we want to filter the orders and get the orders before or after a certain date. So what I'm going to do is take a datetime picker, drop it here, and our business logic in this example is whenever you choose something in that datetime picker, this guy here, we want to query the database, get all of the orders after that date, and then display them in the form.
Okay.
So I'm going to double click on this guy. I get the event handler. And here, so in AT.NET today, what I will have to do is I will have to create a connection and a command or an adapter perhaps, and then fill the data, execute the query, fill the data, and massage it.
Write a bunch of strings for your queries.
Write a bunch of strings for my queries. So a lot of sort of technical stuff that it doesn't have a lot to do with the business logic that I want to write, right? So in this case, I'm going to declare an AdventureWorks DB, which is a type generated by the system that represents the database as a whole. In this case, I'm going to just call it DB. So let's say we have this. I can pass connection string information and related stuff here if I want, but in this case, I'm using the default. Since I just told the system where to connect to because I got the schema from there, it knows that it by default is a reasonable thing to go to the same database at runtime. So this works for the development environment.
In fact, in addition to a connection string, this could be an existing ADO.NET connection.
Absolutely. Yes.
Excellent.
So, and now we have to formulate a query and bind the results to our form. So for this, I could use a bunch of quotes and stuff, or I could actually use language integrated query. So I formulate my query within my programming language, and I get compile time checking and validation, and that's LINQ. Exactly. So let's use LINQ to formulate a query against this database schema that we just imported.
Okay.
So I want to, let me switch back to the form. I want to data bind to this form, which in practice means data bind to this small guy here called sales order binding source. So I'm going to switch to code and say sales order binding source dot data source equals, and now I'm going to write a LINQ query. So I'm going to say from sales order in db dot sales orders where sales order dot order date greater than, and here I want to get the value from the control that the user just changed. In this case is date time picker one dot value select all, and that's it. Basically this is saying from the database, and we know everything that means, like how to get to the database, what is the schema, etc. Use this guy here as the source of data, apply this predicate to choose which element, which objects you want, and pull the results back to the client. This application is actually ready to run. I can execute this, and we get the form. Form is empty for now. Let's change the date to, let's say, 2004. This is going to connect to the database and grab a bunch of sales orders and bind them to the form. Excellent. In this case, it's about like 1,000 or something. So I can move around, and then this is object binding doing its work.
Outstanding.
So this is a very quick overview of a very high-level story, right?
Okay.
So the one thing that is missing here is, so far this looks like a traditional sort of code gen or OR mapper where there's a one-to-one relationship between the database and the view of the database that the application has. It's still a lot of progress in the sense that if we go back to the code, we are using typed objects. You don't have to use rows and columns. Actually, the objects have the properties that represent, each of the various elements that make up the data, and you get, nice query infrastructure based on LINQ. We also handle updates for you, etc. But still, it's very close to the database. So, I guess the next interesting thing to talk about in the context of the entity framework is the entity part of it, or what do we mean when we talk about entities?
Yes, let's talk about that.
So entities, informally, you can think of entities as the elements of your business or problem domain that you're modeling. Like usually you have nouns, right, or things you talk about when you're trying to solve a sort of a business problem or in general writing an application. So entities represents those things, right? When you talk about a customer or a sales order or an asset for an employee, you're talking about these entities, and these entities are not just data, but they represent, there is a boundary to them, like orders and order details may be a reasonable boundary together, where others like customer, maybe they're a single row. They have identity in the sense that when you talk about entities, it is always the case that you have a key and you know how to get back to a given entity. And also there are relationships, like when you know in your system, at least when you're designing it, you know how things relate to each other. And you often tell the system, like if you use one of these database diagram programs, you actually tell the system what the relationships and everything are. It's just that then typical systems today don't leverage quite all of this information. Like we could do more. And
so let me, if I can just say, so from a general purpose programmer perspective, really what you're saying, you're talking about objects and inheritance in terms of relationships.
Yes.
So really entity is just a pretty kind of cool term for object, right? These are objects.
So if we go back to the drawing I'll answer your question in a roundabout way, but if we go back to the drawing that Britt did initially, he noted that there was a difference between the logical model that was in the database, the relational database, and the conceptual model that the application coded against.
Sure.
And there's a couple reasons for that difference. One is, as we saw with Pablo, this logical database may have additional tables, additional concepts, and so forth that the application isn't interested in. So it wants to be able to look at a subset of those. The second is that there may be some mappings between the conceptual model and logical model. So a particular logical concept, or what we call an entity in the conceptual model, may come from multiple different tables in the logical model. So what we describe as an entity is really the representation of the noun, as Pablo said, in the real world. So your sales invoice or your customer or whatever. So the entity is that object you look at, and there's a mapping between that and the storage. Now, a couple interesting things happen here. One of the reasons to have this mapping is because your application wants to really deal in a higher level than what your logical storage is. Another reason for having this mapping is what you were alluding to earlier, which is there are concepts that an object-oriented application has beyond what is directly represented in a relational schema. So those include inheritance, a strong concept of relationships that you can navigate and work with, as Pablo said, a strong concept of identity and reference. So those are all things that you have in the object world that your object-oriented application thinks about, and actually even beyond your application, if you just think in the real world, what types of objects do you have, what types of things do you think about? You have a car. Now that car may be a truck, it may be, or you have a vehicle that may be a truck or a car or a motorcycle or a boat. You have other characteristics. Those are things that you want to model in a more natural way than the tables, rows, and columns that you have in your relational database.
Totally.
So not only might you have a mapping between these, but the concepts you have to deal with at this level are richer than the concepts that you have in the relational model. So if we go back to the example Pablo just gave of using the AdventureWorks database, which ships in SQL Server, there's a lot of normalization that takes place in that relational schema that doesn't reflect the types of things you want to do in your application. So as Britt says, currently all of that logic for mapping that conceptual model, what the objects your application actually deals with, to the logical model and schema is encoded in part of your application in a data access layer. Encoding that logic in here is actually dangerous because you make a lot of assumptions based on the way that the schema is currently generated or laid out in terms of, well, if a sales order has a nullable or a null tax item, then it's an online sales order, and if the tax is non-null, it's a stored sales order. Implicit knowledge about the relationship of different things, how to use a discriminator column to model inheritance between, if you have a vehicle table which may hold cars and buses and trucks and boats, you might have a discriminator that says what type of vehicle it is. That's all logic that is hard-coded into your application, and it's brittle. It breaks. And so that gets into what Britt was saying about the overall cost of your application. It's not just fewer lines to write the application, but it's more cost to maintain that application, because as a developer moves on who wrote those assumptions into the schema and into this mapping, and somebody else comes, they may not understand all of that implicit hard-coded knowledge that's in that code. So our job is to pull out that conceptual layer, to make it real so that you can reason about the objects with the richer concepts, with the entities and entity relationships, and we do all of the mapping, we do all of the work in order to map that to your logical storage.
Precisely.
And Pablo can show a great example of that.
So before we go into the example, just to point out something, now that with this sort of context in place, to answer your specific question, that is, like, are entities just objects? Well, so we automatically provide an object facade for the entities. Now, entities can be used in contexts where there are no CLR objects, meaning that's why we call it a conceptual schema rather than saying we just generate an object model. So the schema that you generate when you design this EDM or entity data model schema is literally it's a conceptual thing, and then you access it with various APIs. You can use the traditional ADO.NET API where you put a query in quotes and you send the query and you get a data reader back with rows and columns, but you're talking to the entities and you get an entity back. I'm going to show that in a second. Or you can choose to put an object face to a result set and say, hey, I want objects back because I'm writing a lot of business logic, and objects is just a more natural representation for representing objects in the context of an application. Certainly. Now, if you're writing like a reporting application, or you have an application that does like ad hoc query, or in general services that are like cross-cutting across various applications and schemas, those tend not to need objects and value talking, like interacting with the system in terms of values is actually is more practical to those systems, right?
And
So
even,
let me just show
even the
you.
application that Pablo just showed, that bound to a form, that application really didn't benefit from the fact that it was objects that it was binding to. It could have bound just as easily to relational records.
The programmer
and not had
did.
to create it. The programmer did in writing the query, and the programmer also benefited from having a richer conceptual model to query against. So if you look at this model right here, really three things are happening. One is we're providing a level of indirection between the application's conceptual schema and the storage schema, and actually you can make changes to the normalization or the layout of your relational schema and map that to your application without breaking your application. The second thing is there's a richer conceptual model that we have here than just in terms of the types of concepts we have, relationships, inheritance, identity, and so forth, than what you have natively within your relational store. And the third thing is object binding. But we actually look at those separately. Whether or not I'm working with objects and binding to objects, I want to work with that same conceptual model. I want the richness of my conceptual model, and then I want to decide, in these cases it's appropriate to use objects, in these other cases it's appropriate just to write directly against the conceptual schema and bring back values.
So think about it this way. Think of entities as having different ways you can present them. If you're in a program, you want to present them as objects. So the presentation of the entity is as an object. It may make sense to present them as XML. I may not want to hydrate them into objects. I may want to transform the entity straight into XML and not incur the process overhead of doing that. Okay. Or if I'm building, if I'm in a reporting environment, I may want to present that entity in a report. It may not be actually materialized, at least from the user that's manipulating the entity into an object. Maybe under the covers it is, but certainly not from the user's perspective. So there's a presentation form of an entity, and obviously in code it's going to be an object in a lot of cases.
So, and then this doesn't beg a question, but I want to take just a little tangent. Are you guys dependent upon the database? So, for example, Jim Gray, right, working on object-oriented databases. How's that going to affect what you do?
So it's
a random question, but it's interesting because right now you're talking about typical relational databases. But
it's a fair question. So basically, the technology that we use now to implement this is we have an infrastructure that we call client views, and we literally have an entire view engine on the client that allows us to create views that are sort of very rich, nested relational views on top of a regular store. Regular in the sense of is a relational store. Those views are powerful in the sense that they are very expressive. They can actually express more than relational. They can express this entity data model, sort of data model where you have relationships and inheritance and so on. And it can also do updates, so it can revert back to relational during update processing to sort of piece apart the things that changed and push them back to the database. Today, we're working under the assumption that the store that we're talking to is relational. But this is for the client views that we're showing here, right? So the architecture itself, what it does is basically there is client views, and the client views hook up at the bottom with regular ADO.NET providers. So as long as you have a provider that you can hook there, and you can interpret, we have a mechanism to exchange, to tell the provider what we want, like what query we want, and the mechanism is provider independent, so the provider can then bridge to the database. So we, like the client views infrastructure, will do the appropriate, view unfolding and decomposition and so on, and eventually we'll go to the provider and say, hey, I want this data filtered this way and sorted this other way, and the provider has to sort of go to the server and provide this data back. How the provider actually does it, we don't care. Right, we have a bunch of rules about what is interaction model and what is the appropriate representation for queries and for result sets, and as long as you follow that, we don't care how you actually are storing the data or even sending the query to the server. If you're sending a query, maybe you're doing something.
So then, and it's it's partly going to be my misinterpretation of what Jim Gray's doing. I'm not a database person; you guys are the experts, but so it doesn't necessarily presuppose that you don't need to have a data provider layer. You can hit the database directly if it's object oriented. That probably doesn't make any sense, but it seems like it could make sense.
It doesn't presuppose that. It presupposes that we are using our intermediate layer. Like
Okay.
whether or not the underlying database is relational or not, we actually don't care. But we don't presuppose that you don't want to use our infrastructure. Like we provide a bunch of services, like identity resolution and change tracking and so on, that we build for every provider to use. And when you are using our layer, you basically are consuming those services out of the ADO.NET Entity Framework stack.
Understood. Which,
So a database vendor, regardless if they have a relational database or an object database or an XML database or any other database, has a couple different ways that they can plug into link. Right. So as Anders said in his talk, basically you can implement iQueryable. If you implement iQueryable, then it's up to you to take the link queries and the expression trees built up, execute them, bring back results as an IEnumerable, and bind them into the application, and then you get all the language comprehension and statement completions and so forth for free. What we've provided is we are ADO.NET. Although the first couple examples that you saw didn't look like ADO.NET, it's really ADO.NET under the covers, and in fact you can code to that level and work with it as values at that level, which Pablo will show us in a second. So we are providing a way that you can plug into Link, or you can plug into existing ADO.NET applications by extending the ADO.NET data provider model, so that you are an ADO.NET data provider. You have connections, you have commands, you return results as data readers. We have one extension that providers implement, which is the ability to take a command and a canonical representation. That is our client view technology that does this mapping, this client views, as Pablo described. It's important to understand that we have this view engine, but we don't actually do any query evaluation on the client. What we do is we do view unfolding, we expand the query that you've expressed in terms of a relational query that we then pass down to the database. And as Pablo says, if you're an ADO.NET data provider and you support these interfaces, we don't care what's beyond that data provider. It can be an object database, it can be an XML database, it can be a relational database or whatever. As long as you support the interfaces, and in particular our canonical way of representing a query, you can go off and do whatever you want and return the results that then we will, through the client views, map back to the set of entities that you wanted, and if you're working at it from an object level or link level, we'll then create the objects and return them to you that way. But the fact that this is built on ADO.NET is really fundamental because we are the ADO.NET team.
Yeah.
We are building this on ADO.NET data providers. We're providing access to this conceptual layer through existing ADO.NET applications. So if you have an existing application, you can take advantage of this technology without having to rewrite. If you're writing new code, as the first example that Pablo showed, you can write that in terms of these higher level concepts. But those are just implemented directly on top of the standard ADO.NET interfaces.
Very cool.
So let's get to a good example of the conceptual model.
So I wanted to show just a quick example of what we mean by a higher level model that is, just not just relational, and then play with it a little bit with the ADO.NET sort of traditional layer, and then throw some objects on top of that.
Okay.
So here's an EDM or entity data model diagram, just like the one we saw before, but this one I prepped ahead of time. And this one is using more the elements of the entity data model. In particular, if you look at this is the diagram that we got originally when we reverse engineered the contents of the database. So here's an interesting fact, and I didn't make this up, this is in a real database. Look at this normalization that happens here. You have contacts and employees and salespersons. So if you want to, let's say you have a sales application and you want to grab a salesperson and you want the name of the guy. Well, it's not in the salesperson table, so you have to go join with the employees table, and it's not there, so you have to go join to the contacts table, and then you first find the first name of the guy. This actually is not, there's nothing wrong with this schema. This schema is just normalized, right? And it may make sense, like there are both functional and non-functional reasons for this to be, to be the way it is.
Right. So this is a schema expressed in logical terms appropriate for a relational database. It's not what a programmer wants, the way the programmer wants to think, which is at the conceptual level.
Exactly.
And so that's
So
the other diagram that Pablo had is moving towards that.
Exactly.
So to use this schema, you would have to do joins between the tables, of course, to get the first name out of the contact table when you wanted to deal with salesperson. And that's an example of how you're cooking into your application details of how the schema is normalized.
Yeah.
So later, if the database admin were to decide, you know what, I'm going to put these together because they're always accessed together and it provides better performance for the applications, it's going to break my application that was doing those joins between the different tables.
So now what you're saying then is if the fundamental architecture of the database changes, your layer handles abstracting that away from me as a programmer.
Typically.
And you don't break my
Yeah.
app.
Typically.
As long as you don't add new tables and remove like fields for good.
Yeah, exactly.
Right?
So there are certain transformations that are possible
That's
and
great.
certain that are not, but we certainly help in that space. Like we help protect the application from schema changes.
Excellent.
The
It's
table,
not-
the data still has to be in the database,
Of course.
right? We can't
Yeah.
make it up.
Yeah.
But a lot of the typical types of things that a DBA may do in order to optimize or change some of the performance characteristics, we can map to. Because the data is still there. They've just changed where it's located, how it's represented.
Sure.
Yeah.
Right.
It's
the,
also
the classic case is where you've got a piece of the system that's really hot, and so it's heavily optimized for transaction processing performance. And then over time, maybe that data changes to more archive interest. So the characteristics for how you want to store it change.
Sure.
Well, in a logical schema, you would actually change the way you stored that data. But why am I going to change my app? I don't need to change my app. So we want to provide independence from that.
That's great.
Which a programmer generally does anyway at some layer in their system. But do we want them to have to maintain that code? No. We want to take on that.
Well, that's what we do for Channel 9, right? We have the interface layer that we use for the database. And every time we want to do something in programming, program against objects, we have to go into the data provider class and fuss around with adding an abstract class and then come back out. And so this is great. This is great stuff.
Yeah, it sort of it not only it isolates you from the database, but also allows you to do these things where not only you are independent from changes in the database, but also let's say here, like you will have to. This is what Mike was saying before. You will have to write joins all over your app. Whenever you want you have a salesperson and you want the name of the guy. Whereas in this schema, there is a salesperson entity. And this salesperson entity, if you can see here, there are attributes that are from the salesperson table, attributes that are from the employees table, and attributes that are from the contacts table. So we have a entity that makes sense for my application, and then you have to provide a mapping specification that describes to the system how to go from one to the other.
Now you did this as the programmer, right? You
Yes,
defined the
yes,
entity.
exactly.
And that's what you expect. I mean, that
Exactly. We expect that what you do is you come here and you go right-click and add new members or add new entities,
Excellent.
and then you provide a map that says how those entities map back to the logical schema of your store. And then when you describe the map, we'll take care of when you're querying for data, we'll shape the data so it looks like the entity that you are asking for. And also when you do updates, we're going to go backwards and we're going to actually piece the thing apart, the changes apart, and push them to the right tables. We can see that in a second. So let me highlight two more details here. So in addition to this, we have two more elements. One is there is a relationship here. Let me move this around. There is this salesperson order relationship. This is an explicit relationship that the system knows about. And we can show in a second that you can use this relationship in your application code. So it's not just a foreign key, primary key thing used for constraint enforcement or stuff like that. This is when you want to go from a person to an order, you actually tell the system, jump over this relationship in a very explicit way. The last thing I wanted to highlight is this guy here. So in the case of this element, which is the sales order, what I chose to do in this particular example is I have a sales order, and then in this supposed scenario, what we have is a shop that has retail stores and also an online presence. So what we do is we have sales orders, and in particular, there are also store sales orders that are sales orders from retail that have tax information. So how do you do this in a regular database? Well, a typical way of doing this is say, well, I'll stick null in the tags. And if it is null, then it's an online thing. And if it's not null, it's a store, right? It's a store sale. Sure, you code that and then you quit, next guy comes in. Nobody knows what null means, right?
Yeah.
So conventions are dangerous. That's one of the problems with databases, right? So, and you use conventions just to circumvent lack of expressivity in certain space of the environment. In this case, for example, instead of a convention, what I'm using inheritance. So I have an entity type called sales order, and I have a subtype called store sales order, which is everything that is a order, but also it has tax information. This is an oversimplified example, of course, but
No, but it's cool because it points out that these are concepts that the programmer, we live and breathe this stuff.
Exactly.
Inheritance.
Exactly.
I mean, it's-
Supernatural. So
Absolutely.
now, when you want only store sales orders instead of all of the orders, you don't say where tax is null. You actually say, give me all of the orders that are store orders. So it's super, super explicit. So once you have this model here, you can use it from objects like we saw before, or you can use it with the traditional, like we call it now low-level stack, because the other one is so high-level and so expressive. So let me quickly show how to actually run this model. Of course, you can use this with link and everything, and maybe we'll show this in a minute. But let me show how this works at the low level. So we said before that objects are just a presentation choice. You can choose objects or rows and columns. In this case, I wanted to quickly walk through a rows and columns example so you can see what it looks like. So if you are used to ADO.NET, this code should look fairly familiar. The sequence here is we declare a connection object, open the guide, and then formulate a command. Here's the query I want to formulate, and I'm going to talk about this in a second. Then call execute reader, get a data reader object back, and then loop through a reader and get the results. So
Yep.
this is vanilla ADO.NET code.
Absolutely.
The only key difference here is I'm using a different provider. I'm using the mapping provider. This is the provider that is sort of the API surface for the client views infrastructure. So what you see through the map providers are entity data models instead of logical schemas. So in this case, I have this connection string information that points me to this model. So what I see is this model. And the tables, which in this case, since we are talking about entities, instead of tables, we call them entity sets. So the entity sets that I have are two, sales orders and sales people. So these are the guys that I can query. So if we come back here,
So this is particularly interesting in that if you have existing code that creates connections, you can pass that right in. You can pass a connection in the map connection. If you've got existing code that creates commands, you can leverage that code. Specifically, if you've got code that today takes a data reader and does something to it, outputs results or whatever else, the end result, although you've queried this richer conceptual model with these richer concepts like inheritance and relationships and so forth in it, the end result at this point is a data reader, and that code that knows how to take a data reader and print it to a file or build a form out of it or whatever else can just consume that. It just works. It is ADO.NET.
so let me point one or two examples. So this guy here looks like SQL. It's a form of SQL that we call entity SQL, and basically it's the way you can query the schemas that are EDM or entity data model schemas. The thing here is, like, if you have a different data model and a client-side views infrastructure, you can no longer rely on the server-side query infrastructure because, at least not the query language, because the server is not going to understand the views that you have on the client or the new elements like inheritance or relationships and stuff like that.
You want the programmer to be able to write queries in terms of their conceptual model. Right?
Exactly.
So that's what entity SQL is all about.
Exactly. So entity SQL is just SQL. It only has a few extra elements in the syntax that allows you to specifically leverage the EDM constructs, just as inheritance or entity types and so on. So let me actually show you a couple of examples. So in this case, I could actually, let me take this back for a second. I could actually write, for example, order date, total due from sales orders. So in this case, I will be querying the sales orders entity set, and I'm projecting out the total of the order and the order date in this case. And this looks pretty much like regular SQL.
It does.
So one of the things I could do is, let me put this value keyword back. I could say, well, I actually don't want just a projection. What I want is, I want the entity itself. By the entity itself, I mean, when you give me the values, just give me the rows with all of the columns, but also preserve the information that makes an entity an entity. For example, the key information, the entity set is coming from, and so on. So when the system gets an entity, it can reason in terms of the metadata that is around the entity. So that's what the value keyword says here. So if I run this query, switch to this guy, this is not going to be super exciting, it's just a console app, so it's going to just output a bunch of order dates and total due numbers. But basically, I'm iterating over all of the orders that I have in this database. So let's try to ask the question that we mentioned before, which is, I want to, not all of the orders, I want the orders that are from retail stores.
Okay.
So in a traditional scenario, I would have to say something like a convention or a bit, column of type bit that says it's a store or not, or whether the tax is null or something. In this case, I'm going to be very explicit, and I'm going to say, you like here, where SP, which is my order, is of, and then here I'm going to point an entity type. In this case, it's going to be Adventure Works, which is the namespace, dot, this is sales order. Oops. And this is my new query. And look at, this is very explicit in the intent, right? I'm saying, give me those where the sales order, which is SP, the variable here, is of this type. Actually, I don't want sales order. All of them are sales order. I want store sales order. So now I'm going to get the subset of these guys that are actually store sales orders. So if I run this, probably there are too many to notice, to make it obvious. But actually, no, I did notice. It's a lot less rows because are only those orders that are store sales orders. So this is a way of leveraging the information that is coming from the model to
Understood.
simplify the way you tell the system what is your intent or what you want from the system.
But you're still writing strings.
Good
in this
question.
Example, because that's great that you use the term is, because we use that a lot. We
Yeah.
want to test the type of a type, right?
Yeah.
So, but there's no way for me to know at compile time whether or not I'm screwed.
Exactly, and that's a good question. So the support for Entity SQL in this context is great for applications that receive ad hoc queries from the user or
Got it.
build queries on the fly, and you want to stay in the value space, as we call it, instead of the object space.
Got
Now, if you want to,
So before you go there, two quick things to note on this example. The first is he wrote Entity SQL. He didn't write SQL Server SQL or Oracle SQL or any other SQL. This SQL worked the same regardless of which backend we're going against, because this is Entity SQL, and we have a common way to pass the query representation to the provider. The second thing to note is that even though it's a traditional ADO.NET application, it's using a richer conceptual schema with these rich concepts like inheritance that is mapped to the relational schema. So in fact, the same application could go against a SQL Server database, a SQL Everywhere database, an Oracle database, an IBM database with different relational schemas, provided those schemas had the same, and the query remains the same, and the conceptual model you're using remains the
Excellent.
same.
Cool.
so that's the advantage of having a full-blown query parser infrastructure on the client.
And
Of
it's
course-
actually SQL language that kind of makes more sense to a developer.
Yeah,
Like the stuff we write today
Absolutely.
doesn't always
Yeah.
make a lot of sense how we have to do relationships
Yeah,
when
right,
we
exactly.
write these strings.
Yeah, this is
and we're not
exactly what I
DBAs.
Right.
Yeah,
Right.
exactly. And also it's completely independent. You learn this, and it's going to work against any database that has a entity framework enabled ADO.NET
Very
provider.
cool.
So it's a very powerful thing. And still, although we we parse the query on the client, we don't do any execution on the client, as Mike said before. We transform this into the appropriate syntax for the server, like working with the provider for that, and then the query is executed on the server. We don't do any evaluation on the client.
Excellent.
So let me show one last quick thing, which is what we did now is we showed basically a more sophisticated schema, and we use that schema using the mapping provider and Entity SQL. Of course, we can also leverage this information in this richer schema using the object layer and using objects as the way to exchange the data and link as the way to formulate the query. So, and even you can mix and match in the sense that if you don't want to use link for whatever reason, like typically you probably want to use link, but if you couldn't for some reason, you can still use an Entity SQL query but hit the object layer.
For instance,
And
we're
it's-
using a non-link enabled language.
For example, in this case, I'm gonna do link. So first, because it's faster to type and everything, and also so we can see the whole thing put together.
Okay.
Let me show you this real quick. Let's say we take this. I'm gonna do data sources. These are two of the objects that we have from the schema. And so let me show you one or two interesting things. Let me grab, let's say, sales orders and put them here. So this is just object binding again. And when the form loads, what I want to load all of the orders, but I want the orders posted by employees or salespersons actually that were hired before certain date.
Okay.
This is an interesting query. It's not like it's rocket science to write this query, but if you have to write this in SQL, you have to join orders with customers, with salespeople, So you get you know which is the salesperson for that particular order, and then join salespersons with employees, so you can get to the hire date of the guy, and then you can have a predicate on that. So you have to wire up a bunch of things, and that is very strongly tied up to the actual database schema. In this case, what I'm going to do is let me declare Adventure Works DB here. Oops. New Adventure Works DB, and here what I'm going to say is I have a sales order binding source. So I'm going to go here and say sales orders binding source data source equals, and now I can write something along the lines of from sales order in db.salesorders, where sales order dot, and I want to talk about the employee, the salesperson. So I'm going to say salesperson dot hire date, and the system knows that this is a relationship traversal because I told the system in the entity data model schema that there is a relationship between these two guys and how this relationship is composed and mapped to the actual store.
Okay.
And this, I can say, for example, greater than certain date. I'm going to just use a constant here, say 2003-11, select the sales order. So if I run this guy, what I'm going to get, not that guy, this guy. So if I run this, what I get is I get the orders from people hired before or after, in this case, certain date, right? And you're going to have to believe me because there's a lot of data there.
Sure.
So it is very expressive in the sense that now when you read the query, you know exactly what we mean by it.
Mm-hmm.
Let me show you one last example before we finish. So in this case, what we addressed here is the fact that since there is a bunch of relationships and a mix of that with sort of normalization,
mm-hmm.
then it will be a lot of things to write the query using regular languages, and here we have like the infrastructure plus link is given a very high level and straightforward way of building the query. Let me give you an example that is slightly different from the sort of problem space perspective. We talked before about the database being very heavily normalized. So in this case, we had like contacts and employees and salespersons. But my system has only salespeople, and that's all I want to know about. So what I do here is, for example, let me get rid of this guy and take the salesperson entity, stick it here. So note two things about this. First of all, if I want to query this, I would say something like salespeople, salesperson, not that guy. We want the salesperson binding source, which allows us to do data binding, and then let's do this query. We want to say something like, give me all of the salespersons before certain date, for example. So I can say from sp in db.salespeople, where sp.hiredate greater than, let's say, same date as before, 2003-11, select the salesperson. So when we run this query, we actually are using one table name, so to speak, which in this case is salespeople. But actually, under the covers, we are grabbing this data from all of these various tables. Like the hire date is coming from the employee, for example, and the first name is coming from the contacts table. So this brings the question: how do you update this thing? Like in ADO.NET was already tricky to do updates because you had to create this adapter, and the adapter had to have an update and insert and a delete command for every table. So it was a lot of setup work to get this working. Let's look at the ADO.NET Entity Framework version of update. What I'm going to do here is go to the toolbar, enable the update button from the object binding source, and so the objects are bound to the UI. So as you change the UI, the system actually changes the objects. So it's the same as you in your business logic code changing the members of the object, and it works either way. Either you change them or the system, like the UI, changes them. Once you're done with the changes, you simply say save changes. Meaning you tell the system that you're done with it and you want to reflect the changes back in the database. So to show you what's going on under the covers, let me enable, this is SQL profiler, so we know what's going on under the covers. So I'm going to execute this. And so here are a few entities that I have. So let's take one random one, let's say this one. I'm going to change the hire date, which if you remember, it was in the employees table.
Okay.
And then let's change the bonus of the guy. We're going to give him like a promotion. So we're going to change the bonus, and the bonus was in the salesperson table. So when I move off the row, this is changed like in memory, and when I hit save, this is gonna be saved back in the database.
So that calls submit changes.
So this guy called this guy here, and what this guy did is, if we go to the profiler, so what we did is we computed what are the actual minimum changes that were required for this particular scenario, and in this case it was 2 changes, one to the employees table and one to the, I think the other is the salesperson table. So we basically take care of going from the logical schema into the conceptual model, and then back from the conceptual model into the logical schema without you having to deal with this at all. Which is important.
So the programmer never had to leave their conceptual view of the data, and you can see here from the tool we've got, you can see underneath the covers, we're able to take care of that.
It didn't have to write the update code in SQL themselves.
That's right.
And forget or add, say, for example, no lock.
Yeah.
Or do something stupid and not understand what they're doing.
It's worth mentioning here really quickly that one of the things that we hear from people when we talk about this is, well, why don't I just create views in my relational database to do this? Well, it's not always the case, but often the case that the updatability characteristics of views are actually less in the relational database than they would be in the infrastructure that we have. So there's a lot of research and stuff by that we can save. We can save for a later date. Our friends at MSR have done some of that for us. But that's an important concept as well. We relieve the programmer from having to be concerned about, well, if I create these views in my logical schema, are they actually going to be updatable? Because they may not be. So you don't have to worry about trying to fake it, if you will, at the logical level. You can just operate at the conceptual level.
Outstanding.
Okay.
Well, that's great.
So this is still it's a working version. We're working on it really hard, and so we are actually going to be coming out with bits soon.
So like a CTP or something?
So yeah, exactly.
Yeah.
We're going to be doing a CTP. We're shooting for the August time frame, give or take. So if you're interested,
Hey,
in
your
the topic,
demos work. Ship it.
yeah, that works.
Exactly.
Maybe we're done. So if you are interested in the topic, I would highly encourage you to go out there, get the bits, play with them, and send feedback this way. We're really, really interested in knowing what do you guys think about this stuff. Like, does it work for you? Is it a good idea? Is it the right stuff?
So now the question that I would ask is, for general purpose programmers in the IDE, debugging is like just a beautiful, wonderful thing.
Yeah.
So, I can debug into the schema, I guess, or into the thing that generated that you guys.
Yeah,
anything I can debug. Are you debuggable?
Yeah, absolutely.
My question.
In various senses. Like, so the code that we generate is just regular open code. So you can step into we generate code only for the entity definitions and the view, the CLR view of them. So it's just regular code. It's part of your project, so you can debug through them. Also, like the link query that you can see here, for example, or the entity SQL query, we're working on having diagnostics infrastructure, so you can see what we generate in the other end of the pipeline, and you can tell where the query that we're sending may be the problem that you're having, or maybe we're interpreting the query one way and you expected us to do something else with it, or stuff like that. So
the fact that the query ultimately goes to the database means you've got all the database tools for finding out what really hit the database. So as Pablo showed, if you want to know what really happened when you updated that entity, you can go into SQL Profiler for SQL Server, and it'll tell you these 2 update statements got made.
Very cool. Nice job, guys. This is very interesting stuff. And so, where do developers give you feedback? Like when not fun. Do they just go to the feedback center, or is there any? You guys have a blog?
No, we actually have. So we have a blog, and we have a forum in the MSDN forums.
Excellent.
So blog is in data access. So it's MSDN blogs.msdn.com/data access.
Great.
So you can go there and read about what all of the stuff that we're doing. We also link to personal blogs of other people and so on. You want to add it to my favorites?
Yep. We'll be checking that daily.
Also show them the data blog, just whack data.
Sure. There is also
sort of a on the conceptual side. I use that word.
Yeah.
We have a blog that just talks about kind of our vision for data access and where we're going there, and that's on the data.
Very cool.
So these are two interesting points. We read these all the time. So if you post feedback there, we're definitely going to read it. And there is also, we have forums in, I think it's forums.
Forums.msn.com, something like
There,
that.
yeah, or
They copied Channel 9, you know.
yeah, sure. So there are forums. There is a specific forum there.
Just kidding,
that talks
Josh.
about- there is a forum there that talks specifically about the future versions of
Cool.
ADO.NET. So just post
And also,
stuff there.
you know, this video, my hope is that all of you will interact with Niners, because we have a lot of
Absolutely.
Niners that actually
Yeah.
are sort of IT developer types.
Sure,
Yeah.
absolutely.
They're going to eat up this kind of content.
Yeah, sure.
And will want to
We'll be-
interact with you.
Yeah,
So this
we'll
will be
be-
a logical thread for you to interact with.
Absolutely.
It's easy to become a Niner.
We'll be listening.
Nice.
We'll be listening.
Yeah.
Cool. All right. Well, hey, thanks for your time.
Hey,
Thank you.
See ya.
Bye.